Hi, Assalamu alaikum everyone. Um I was expected to prepare a lesson, record it, and with the board and all that. I felt like the video wasn't coming out clear, so I am now recording a lecture video on the board, on the digital board. So let's start. My topic was I've selected like linear algebra. So the first thing is that your students need to understand what does linear algebra mean. What is a linear algebra? It's a branch of mathematics that is concerned with the mathematical structure. More very important statement over here. Mathematical structure closed under the operations of addition and scalar multiplication that includes number one, the theory of systems of linear equation. That's what I need to discuss today. Furthermore, there are more operations, that is matrices, determinants, vectors, vector spaces, and linear transformations. I will be discussing the theory of linear equations. Before I start, the theory of linear equation, students need to understand what is the system of linear equation. What is a linear equation? Linear equation is a format where you have a variable, more than one variable, multiplied with a quotient, addition or subtraction expression. It looks like this. There's an A1, which is a quotient, A2, a different quotient, could be repeated one, but related to the other one. And there comes the variable x1, x2, up to xn. Xn means you can have more than one variables involved in one linear equation. Coming to the other side, there's a constant on the other side. So alphabets in the form of A and B will be numbers, and x1, x2, up to xn, as many there are, could be variables. What I mean to say, it could take the form of x1, x2, x3, or it could be x, y, z, any one of them. You can see over here in this equation, the quotient is 2, and as there's nothing with the y, means there is 1, and then the quotient of z is minus 5. Minus 5. On the other side, in the place of b, there's a constant that is 7. Looking at the variables condition, the variable is x, the other variable is not x2, it is y, and the third variable is z. That shows that you can have x1, x2, x3 as your variables, or you can also have x, y, z as your variables. Second format of the equation, linear equation, you can see looks a little bit different but means the same thing. It is a linear equation. Here, let me just break it down. Minus x1 means minus 1 is the quotient and x1 is your variable, plus there is a pi sign which has a value 3.14, let's say, and then x3 is your variable, and minus under root 3 is your quotient, under 2, sorry, and the variable is x4. You can notice that x2 is missing. That means x2 had 0 next to it. That's why it's not there anymore. Equals 0.07. Shows it can be a linear equation even if the quotients are negative, decimal format, or in a square root format. The equation can take the shape of a linear equation. Coming to the next one. A few more examples over here. You can see the two sets of examples. Number one, where the equation is a linear equation, and the other one where it's not. Looking at this equation, what you see, 4x1 minus 5x2 plus 2 equals to x1. If I rearrange it, this would be 4x1, bringing the x1 on the side of the equal, minus x1 minus 5x2, and let's take the quotient, the constant to the other side of the equal becomes minus 2. Solve this part, becomes 3x1 minus 5x2, and then there is equals to minus 2. There it is. So there is a quotient. X is this format, minus 5 second quotient, x2 is equal to minus 2. Looking at the second equation, this one is a bit different than this one, but you can look at it. X2, let's open up the bracket. 2 under root 6 minus 2x1 plus x3. Rearranging, you will get this format. Both the equations are linear equations. Looking at the nonlinear format, what's different between this equation and these is you can see that 4x1 is a standard format of linear equation, minus 6 into x2 also a standard form of linear equation, but on the other side what you see is two variables being multiplied. X1 is being multiplied by x2, which is not possible in a linear equation. That's the reason it's not a linear equation. Looking over here, x2 standard format minus 2 under root x1 equals minus 7. What's wrong over here? This is what is wrong. Your variable's power is, the power of your variable is 1 over 2. That is not possible in a linear equation. That's why this equation, this example is not a linear equation example. Coming to the next one. Solving linear equation. Now, linear equation, when you're solving them, as many variables you have x1 and x2 only in your equation, then you'll have two solutions. If you have x3, then you'll have three solutions. That's how it works. And you'll have a value of x1 and then you'll have a value of x2. Two examples on this side. This one, it's written over here, it has one unique solution. And over here, you can see no solution. By one unique solution means there would be a value of x1, which will have one value, and x2 will have also one value. Coming here, wherever they intersect each other, the value mentioned over here would be the value of x1 and x2. If these variables had a different format, things would have been different, like quadratic equation or something like that. Looking at this example, two lines are totally parallel to each other. There is no way they will intersect each other at any point. If they are not intersecting each other, they will not have any solution. There is no solution of x1 or x2. That's quite clear over here. Yes, if they would have started off somewhere and here, so fine, this is the solution, points noted, and whatever this is, x1 is equal to value over here, x2 is equal to value over here, one value of each variable. That's as simple as that. But looking at the situation, parallel lines, no, there is no solution. Next one, let's see. Check if the solution is correct. Okay, looking at the question, to check if x is equal to 3, y is equal to 4, and z is equal to minus 5 is a solution to the equation. How do we do that? As simple as that. Substitute the values of the variable in your equation on one side and check if it's equal to this. So let's start. X becomes 3 minus 4 into what is the value of y? It's 4 minus 6 into minus 5. Is it equal to 17? Let's see. 3 minus 16 plus 30 equals 17. Go ahead and check it. Is it? Yes, it is. So we have 17 equals 17. Coming to the next question. Okay, when you have a solution to the system of linear equation, three values given, looking over here, 2x1 minus x2 plus 1.5x3 equals 8. Are these three values solution to this equation? Let's see. 2 into minus 3 minus 8 plus 1.5 into 4. Is it equal to 8? Let's see. minus 6 plus 8, 1.5 multiplied by 4 equals 6. And is it equal to 8 or no? Yes, it is. You can see that 8 equals to 8. But there's a problem. There are two equations over here. So these values need to be true for both of them. Let's check this one. x1 is equal to minus 3, minus 4 into minus 8. And that is x3. So that's not right. Let's go for minus 3 minus 4 into 4 equals minus 7. Minus 3 minus 16 equals minus 7. Is it? Minus 19 is not equal to minus 7. So this is not the solution of the system of the following equations. Okay, we are done for this part. Let's go for the differential equation. Differential equation, you must have some foundation from the previous classes, but let's start. What is the definition of differential equation? A differential equation is an equation with a function and one or more of the derivatives. It's a function and that has one or more derivatives. So that shows that there can be more derivatives of a single function. In other words, in easier words, a differential equation is an equation that contains one or more terms and the derivatives of one variable. Means you're differentiating with respect to one particular variable. That is the dependent variable. You're talking about dependent variable with respect to the other variable, the independent variable. In this case, what do we have? We have y is the dependent variable, x is the independent variable. Means any change of y is caused by x. So it doesn't change on its own. It changes only if x changes. Order of the differential equation, very simple. The order of differential equation is the order of the highest order derivatives present in the equation. Highest derivative means the maximum number of derivatives you can draw out of it. Looking at this one, this is the highest level. If you take another derivative, there wouldn't be the variable left. So dy over dx is equal to 3x plus 2 means it's been differentiated. Derivative has been taken only once. So the order of the equation is 1. Here, this is this format typing error. D square y over dx square means the derivative was taken twice. Once the derivative was taken of another derivative. So that's why you ended up with this form. It was taken twice. That's why the order is 2. Here again the highest format of the derivative is 1. And I think we are done for this. Enough time done.